Okay, so we're going to move on a little bit and talk about how we can create logic control with valves. So how we can make things happen when there's more than one input, right? So the whole purpose of this one is going to be logic between 3-2 valves. Now you guys should already understand what I'm talking about when I say logic. So we're going to concern ourselves principally with AND relationships and OR relationships. So let's say we want a cylinder to outstroke when valve 1 and valve 2 are on, as opposed to wanting a cylinder to outstroke if it's valve 1 or valve 2 that's on. How do we achieve that? So as far as AND control goes, if I got that pasted, I do, right? So as far as AND control is concerned, we might have, I'm just going to stick to push button spring return here, right? Push button, spring return, and let's get a cylinder. Single acting will do the now. We're going to focus on AND first of all, so let's get rid of OR. Okay. So simple issue is that we want the cylinder to outstroke I want 2 valves to be able to control this. I'll give some setups for in some context in a wee minute, right? So we want 2 valves to be able to control this single acting cylinder. How can we get 2 valves? So we want the cylinder to outstroke if this one and this one is pressed, and only in that instance. So we want a main air signal here if both of these are pressed. How do we achieve that? So we're going to provide one of the valves with a main air signal and an exhaust. The exhaust is pretty much always there on the valves we use anyway. If we send that main air signal to that cylinder, then that would mean if the person presses that button, the cylinder will outstroke regardless of this guy. So this must not go to the cylinder, it must go to that second valve, and then that connection is made. So the only way we can get main air to this cylinder is if that button is pressed and at the same time this button is pressed. This is AND control, and we can AND as many valves as we want. We could put 2, 3, 4, 5, 6, 7, however many in a line. They would all have to be on in order for the cylinder to outstroke. This is AND control. The pneumatic circuits that we're doing are going to get a little bit more complex the further on we go. It won't always be the case that valves are directly, like 3-2 valves like this, it won't always be the case that they are directly controlling a cylinder. So what's important is you think about signals. So this is the signal to outstroke the cylinder down here. Alright, it's connected directly to the cylinder in this case. It won't always be. But it's the signal, the outstroke signal that we care about. So this outstroke signal is a result of valve 1 and valve 2. It's going to be pretty common for us moving forward to name our valves and our cylinders. Right? So that when we do our descriptions can be relatively short. So I'm going to ask you to do parts lists. The parts list is where you prove you know the names of everything. I'm also going to ask you to do descriptions. You don't have to prove you know the names of everything during the description, you just have to prove you know how it works. So in the parts list you would say push button spring return 3-2 valve is valve 1, valve 2 is a push button spring return 3-2 valve, cylinder A is a single acting cylinder, proving that you know the terminology. In the description you would say cylinder A will outstroke if a user presses both valve 1 and valve 2 at the same time. So it shortens your descriptions, and so with the parts list you get a chance to prove your knowledge, and with the description you get a chance to prove that you know how it works. Yeah, so I'm just going to connect that up there, and then I'm going to stick the parts list and description in. Okay, so this is a description of AND control. In the description we'll use the word AND. Okay, let's look at the next logic function, which will be OR control. I'm just going to sketch, right, just for speed. So let's stick with a single acting cylinder. A. And in this instance we're going to have two of the 3-2 valves, and in this instance it probably would be quicker. Paste them. Again, there's two of them. Now in this instance I'm just going to flip this guy because I know what's coming. Oh, there. And then give them names. 1, 2. So I want cylinder A to outstroke if valve 1 or valve 2 is pressed. So essentially, if this has got its own main air signal and exhaust, and this has got its own main air signal and exhaust, if somebody presses this one, I want a main air to go here, and if somebody presses this one, I want a main air to go here. So you would think that you would just do that. A T-piece in there, wouldn't you? You would think that was easy, but it's not. So don't assume that that's the answer. I'm just going to explain why that's wrong. Okay, the reason it's wrong is that if a person presses that button, what we've got is this state active. So main air is connected to this port, and we'll have an immediate increase in air pressure, and we need that air pressure to move this guy out. However, at the T-piece, that air pressure's got a choice. It can go up to the cylinder, or it can go straight onto this other valve, and notice in this instance that output is connected currently to exhaust. It's connected to the room. So basically if you press that button, that air pressure will just be released out of the exhaust on the other valve and may not build enough pressure to outstroke that cylinder. Or even if it does, it probably won't be that strong, right? And you would immediately get air coming out of the other valve. So using a T-piece for OR isn't going to happen. In actuality, we need an intelligent T-piece. And we've got an intelligent T-piece, and it's got a name. Okay, I'm going to introduce you to a new component. And we pretty much only use this component for OR control. The new component is called a shuttle valve. And it's very similar to a T-piece, where you've got this connection here. Right, so it looks like a T-piece so far. You draw a box around it. So there's your 3 connections on the outside, and then you include this on the inside. That's the symbol for a shuttle valve, where this is the output port, and this is input 1, and this is input 2. So the idea is, what's this representing? And we'll see this symbol coming up quite a lot in pneumatics. So this is a ball and cone. Okay, so you could imagine that the inside channel of all of these things is a cylindrical void. Yeah, the inside of the hose is a cylindrical void the air can flow through. If we put a ball inside there, if we provide an air supply here, let's just try and make that look a wee bit 3D there. Yeah. If we put an air supply in this end of the hose, it would push the ball along the hose and the ball would come out the other end. If we put a square section inside here, it's difficult to describe, but the channel that runs along here isn't circular the whole way, then the ball could strike the end of that and not be able to travel through it, but air would be able to get around it. Or alternatively, the square's big enough for the ball to go inside, and you put a perforated baffle in there, lots of holes in it. The ball would get in there and sit against the perforated baffle, and the air would be able to go around the ball. Yeah, so the ball wouldn't be able to move along the tube, but air would be able to get around it. Alternatively, what we could do is we could have the inside tube shaped like that, it's all circular. But at one end it comes down to a smaller diameter. So if we push the ball along that, the ball will sit snugly in there and completely block that. So the air won't be able to flow through there. And then if we put air in this side, it would blow the ball out of the cone. That's what's happening here. If you put air into input 1, it will blow the ball over and block that cone. So no air will come out of input 2. The only path is out the output. If you put air into input 2, it will blow the ball out of that cone and into that one, blocking an output path here. So air can only go out the output. So you show the symbol for input 1 connected to the output. If you provide an air signal to input 2, the ball would move over and input 2 would be connected to the output. That's a shuttle valve. Shuttle is a word we use in pneumatics to mean something can move from left to right or can move backwards and forwards. Something can reciprocate. Okay, so that wee ball can shuttle between those two positions. If you provide an air signal on both at the same time, if both air pressures are identical, then technically the ball, the ball will actually get stuck in the middle position, and you'll get air coming out the output, but you don't really know if it's input 1 or input 2 that's causing it. Okay, this is what a shuttle valve is. Got one in real life to show you. I just want you to compare it to the. If you compare it to the T-piece, make it bigger again. So there's the unintelligent T-piece, and there's the shuttle valve. So you see it's much bigger. Still only got 3 connections on it. The 2 horizontal ones are your inputs, and the one that sticks out the top is the output. I don't know if you can see, it's got the symbol stamped on it as well. Yeah, top centre there. That's a shuttle valve in real life. Maybe a good idea to sketch that and label it, input port, output port. Sketch the body of it, the real one, next to the symbol of it with the name. Take a note of it. And that's how we achieve OR control. So that's not happening. I didn't have to rub it out, I just realised. Because the T-piece does form part of this shuttle valve symbol. Like that, ball in there, you can draw the box around it. Bish bash bosh, and that's a shuttle valve. That's where the intelligence comes from, so that when you provide this air signal, it can't just come out that exhaust port, because it can't even get out the shuttle valve. All of that air pressure goes to outstroke. Okay, again, I'd like to see a parts list. Ooh. Let's copy that. Parts list and description, please. I'm not going to do this one, I'm going to let you do it. I want to see your parts list in your description. So that's and an OR, and then I'm going to give you 2 circuits to design again. And again, I want to see the circuit drawing, I want a parts list, and I want a description. And this time when you design your circuit, give them names like this. Number your valves, letter your cylinders, and then in your description just use the terms valve 1 and valve 2, because you've already proven that you know the names in the parts list. Hopefully. So let me add these 2 circuits. Let me add all the questions. Okay. Okay, so these are the questions that I want you to do. So these are the things from this presentation. Copy out the circuits, part list and description. For AND control, for OR control, the shuttle valve, and then you need to finish the OR control one, because the OR control one doesn't have a parts list or description. I then want you to design these 2 systems. Now before you do these 2, I've got an example that I'm going to talk you through. Okay, so on this page here, create a pneumatic system which will push open a door if either one of 2 valves are actuated. The valves are actuated by solenoids. The door will close automatically when the solenoid is switched off. I'm going to use this as an example, and what I want to see is the circuit, the parts list and the description. It says that I'm using this solenoids as an example because I want you to see solenoids used before you ever try to draw anything with them. All the other ones are kind of solenoids and diaphragms are kind of special cases. All the other ones are quite simple. Right, so the door will close automatically when the solenoid is switched off. That's a kind of easy way of telling us that it's a single acting cylinder that we're using. So single acting cylinder. Okay. And it says, and you know already these questions are based on logic, so it says when either one of two valves are actuated. So I've tried to write that in a way where I haven't used the word or, but either one of two means one or two, so we're going to have a shuttle valve controlling this then. So this is going to come down from here through there. There's going to be two valves controlled by a shuttle valve. My system's starting to lag a wee bit, I need to be careful. And then I've got two 3-2 valves. Both controlled by solenoids. Yeah, my system's lagging. Why does this? Now that could be enough on its own, but with solenoids sometimes it pays sometimes it pays to, or sometimes you might have to identify. So there you go, you've got an OR control, so a single acting cylinder controlled through OR with two solenoid spring 3-2 valves. Sometimes it pays to label these two connections because these are the two electrical connections. So you would say from electrical system. Yeah, I'll write it somewhere else and move it over. There you go. And then obviously your parts list and your description. So your parts list would be, come on, single acting cylinder. Don't ever abbreviate in a parts list or when you're asked to name components. And then you've got solenoid spring 3-2 valve times 2, and then a shuttle valve times 1, and then a description. Let me just tidy this up a wee bit. Oh, don't want to do that. Group, make it smaller. So then our description is, let's give them names. So that's going to be A1, 2, 3. So make sure your description references everything. So we'd say cylinder A outstrokes when valve 1 or valve 2 is actuated. Valve 3 provides this OR control. Okay, that's your description. So that's what I'm looking for. That's the level of response and the kind of language that I'm looking for out of your responses to these questions. Hopefully a little bit neater than that, because you can take your time over it. There you go. Right, so these are the questions you're doing. Get that stuff done. Thank you.